We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Meeting recording is in progress. Okay. And now I would like to share the content. Okay. So from the beginning, at first year level, fine. If we discuss why pile foundation is required, then normally the students saying that bearing capacity, soil is poor, or load from structure is higher, so pile foundation is required. But now we are in 8th semester of the civil engineering, so we do have some numerical values so that we can decide on a same soil whether we can go for isolated footing, we can go for raft footing, or we can go for pile foundation. So it depends on a bearing capacity of the soil and the structural load on the soil. Okay. So let this red boundary here is a plot boundary and black boundary is a structural boundary. Means our civil engineering structure is lying within the black boundary. Okay. And it is provided 4 meter by 4 meter grid. Okay. There will be a 4 meter by 4 meter grid and columns are provided. Here it is. Now, if we take a central column for the load calculation, as we have discussed at the DR.S level, but before that, let's study structural data. Column grid is 4 meter by 4 meter. Plot dimension is 58 meter by 3 meter. Safe bearing capacity 250 kilonewton per meter square, which is considered as a very good bearing capacity. Okay. Now we shall discuss what the load is coming on this column approximately. So column load from the single story. Slab load, let we assume slab load is 6 kilonewton per meter square. How it is possible? For example, 4 meter by 4 meter slab grid is there. So minimum 110 mm thick slab will be required. So 2.75 kilonewton per meter square will be the slab load. 2 kilonewton per meter square will be the live load. And 1 kilonewton per meter square is the floor finishing load. So total 5.75 kilonewton per meter square load. So we take 6 kilonewton per meter square load. Fine. Wall load 14 kilonewton per meter we assume, because if we consider 23 mm thick wall, 3 meter height, so it will generate the UDL of 14 kilonewton per meter. So if we discuss this central column, so it will support a slab of this red boundary and it will support the walls of this purple boundary. So slab load will be, as the grid is 4 meter by 4 meter over here, so this slab area will also 4 meter by 4 meter and slab intensity is 6. So 4 into 4, 16, 16 into 6, 96 kilonewton. Wall load on the column. So this is 2 meter, this is 2 meter, become 4 meter and this is also 4 meter. So 8 meter is there. So 8 into 14, 112 kilonewton. Total load on the column, that is 96 plus 112, 208 kilonewton. And if I make it factor, then it would be a 312 kilonewton load on this single story column. So normally all the column will apply same load. Fine. Now see what happens if it is a G plus 3 story building. Okay. So total load will be 1036 kilonewton. So my area required is 136 by 250 column load upon safe load bearing capacity 414 meter. We assume square right now. The side of the footing will be under root of 414, 203 meter. Okay. Why isolated footing is okay? I am writing here because 2.03 meter from center it is 1 meter, from center it is 1 meter. Okay, so no overlap of the footing is still there. I can go for the isolated footing. Fine. What happens if same structure is applied for the G plus 6? What will be the load? Then load become 1872 kilonewton. Area required is 7.5 meter square. Side is 2.73. Okay. Still isolated footing is okay because this is the center to center distance between half distance of the column and my footing is less than half area. Suppose now it is a G plus 10 story building. Okay. Then my total load will be 3120 kilonewton. Area required will be 12.5 meters square. And my side of the footing will be 3.53 meter. And if I divide 3.53 by 2, it will give me nearly 1.75. So still this is 2 meter. Please understand, this is 2 meter. So still I can provide isolated footing. G plus 10 story building. The footing, this is the footing boundary. But now I am going for G plus 13 story structure. So my load becomes 4656 kilonewton. And area of footing is required 16.22 meter square. My side will be 4.02 meter. So now isolated footing is not okay because my side, half side is going to more than 2 meter. My footing is going to overlap. Okay. And every footing is making overlap. So I am choosing here raft foundation. Still I am not touching the pile foundation. Please understand. So now we will check whether our bearing capacity is safe or not for raft foundation. So total load on the structure will be total 78 columns are there. One column is 312. 13 stories are there. So my total load is 316368 kilonewton. My plot boundary is 58 by 30 meters square. I can provide an entire footing on my plot boundary. Okay, so I am utilizing full plot boundary. So my upward pressure is 181.82 kilonewton per meter square, which is less than SBC. So raft foundation is okay. Now suppose G plus 70 story I am going. Okay, so now it is clear that I have to provide a raft foundation. So now I am checking for safe bearing capacity. So first of all, total load is 413712. So upward pressure is still 237. So raft foundation is okay. Now suppose 18 story, because now I am increasing by only one story. So total load become 438,048. And upward soil pressure is 251.75, which is greater than 250 kilonewton per meter square. So my raft foundation is not suitable here. So now I have to think for pile foundation, even though my SBC is 250 kilonewton per meter square, which is considered as a good bearing capacity. So every time poor bearing capacity cannot be the reason for choosing a pile foundation. This is the introduction at final year level. Okay. Now types of the file. So there are many classification and types of the file based on the material, based on the load transferring, but we will discuss only two types of the pile here: end bearing pile and friction pile. There are a lot more classification. Okay. The type in the soil in which piles is installed may be cohesionless or cohesive soil. So for both the type of the soil, we have a different formula. So pile load carrying capacity calculated with different equation for cohesionless and cohesive soil. So first we discuss cohesionless soil. So my total capacity will be end bearing plus friction. Okay. For end bearing calculation, we will use the bearing capacity equation CNC gamma D NQ plus 0.5 B gamma N gamma. But as we mentioned that the soil is a cohesionless soil. So C terms is going to be 0. So this term is 0. First step is 0 as soil is cohesionless. This third step is having a value very, very less. So we ignore it. So our equation will be reduced to gamma D and Q. But here we cannot take a full depth of the foundation, but we will consider a critical depth only. So how to choose critical depth? Okay. So critical depth 15D for the loose sand. Here D is the side of the pile, square, rectangle or circular. Minimum dimension we will consider here. Okay. And friction resistance K into tan delta into area of pressure diagram. This will be our pressure diagram. So up to critical depth, my pressure is increased linearly. Then it will become constant. So I cannot take full gamma D. Suppose my pile is at 20 meter depth. So I can't consider unit weight into 20 into NQ. I have to restrict up to the critical depth. Okay. So now we shall take one problem over here. A 10 meter long concrete pile of 500 mm diameter. D1 into the loose sand, phi is equal to 40 degree. Unit weight 70 kilonewton per meter cube, NQ 135, and factor of safety is 3. So first of all, we will generate the pressure diagram of it. And hence it is a loose sand. So critical depth will be 10 into B. So 10 into 0.5, I will get 5 meter. So up to 5 meter, it will increase linearly and then it will become constant. And so 5 into 75, I will get 85. Okay, so first of all, we shall calculate now end bearing resistance. Area of pile pi by 4 into d square 0.196 meter square. Unit Q, that is the bearing capacity, will be unit weight into the critical depth. So I will get it. My critical depth is 10 into 0.5. Pressure intensity will be 5 into 17, 85 kilonewton per meter square. So end bearing resistance will be 85 and Q value is given 135 multiplied by area. So 2249.1 kilonewton is my end bearing over here. This is 5 meter, 5 meter. Fine. Now frictional resistance. So for friction resistance, K and delta value is given in this table. But majority in exam you must be given. Sometimes it is given take K into tan delta value this much. Okay. If it is not given, then we have to remember this table. So you can remember this table. For the loose sand and dense sand, what is the K value based on the pile material, that is steel, concrete and timber. What will be the delta value based on the phi, and what will be the K value. Now frictional resistance. So it is a K into tan delta into area of the pressure diagram into the perimeter of the pile. Okay. So now this would become 40 degrees. So concrete 0.75 delta, tan 30. K value is 1. Okay. Pressure diagram. So this much area 0.5 into 5 into 85. This area rectangle below rectangle 5 into 85 and perimeter. So my capacity is 809.40 kilonewton. Total capacity is 3058.5 kilonewton divided by factor of safety 3. My total capacity is 1019.5 kilonewton. Okay. Now there may be a different type of the stratification. This is a uniform. Okay. Now same problem we consider with the effect of the water table. In a previous problem, effect of the water table was not there. Okay. So here we consider now the water table is 3 meters from the ground level. Now see what happened here. So my bearing capacity will reduce to 65.38 kilonewton per meter square. And from where I got this, that I will see here. end bearing resistance. First of all, area of pile is same, unit weight into the critical depth, and submerged weight. If it is not given, you take unit weight of water 9.81. Majority sometime it is given 10. So you can directly take 17 minus 10, so it will be 7. But here, if not given, then we will use standard 9.81. So submerged weight becomes 7.19 kilonewton per meter cube. So how I will get the surcharge value? That is critical depth is okay. So pressure intensity will be above ground water table. My unit weight is 17, so 3 into 17. Below groundwater table, my unit weight is 7.19, so 2 into 7.19. This is the only change that we have to keep in mind. So now my bearing capacity at the end is 65.38 kilonewton per meter square. So my end bearing is 1730 kilonewton. Previously it was 2200, now only 1700. Okay. Frictional resistance, same 10 delta into 1 into area of pressure diagram into perimeter, so it will reduce to 44.70 kilonewton. Total capacity of the pile with factor of safety 3 reduced to 724.09. So as water table increases, pile load carrying capacity is decreases. Fine. So we will discuss here two problem of the pile foundation in cohesionless soil. Now we shall discuss a pile foundation problem in a cohesive soil. Okay, that simple one. Take one problem. We will discuss the theory also as well as the numerical also. So let 9 meter pile length is there, 30 centimeter dia. The soil characteristics is 1. Here it is given unconfined compressive strength 160 kilonewton per meter square. Factor of safety 2.5 and alpha is 0.75. This is the data given. But before that, we shall simply discuss the theory of the load carrying capacity. So total capacity is QP plus QF. QP end bearing, QF frictional resistance. End bearing is QP into AP. QP is the bearing capacity, and that is equal to C and C. QP is equal to C and C. C is the cohesion, and NC you take 9 without any discussion. Frictional resistance will be friction into the frictional surface area of the pile, AS, area of the surface. So friction is a adhesion factor into cohesion, and surface area is the perimeter into the depth or length of the pile. So now we see the solution. So end bearing capacity, here in this problem we are given unconfined compressive strength of 160 kilonewton per meter square. So cohesion will be half of it. So I can calculate QP, that is 9 into 80 into 0.07. This is the area of pile. So my end bearing resistance is 50.9 kilonewton. Frictional resistance into the area, surface area. So alpha into C, P into D. Alpha 0.75 given in the problem. Cohesion 80, we calculate it. Perimeter pi D 0.942 and depth is 9 meters. So 509 kilonewton. Here one thing you please note. In many problem, they said neglect end bearing. So we can see here the frictional resistance is 509. End bearing is 50.9. It is a 10% of it. So that's why many book also neglecting the end bearing. But if it is not mentioned in the problem, we will calculate end bearing also. Right? So total capacity of the pile is 59 plus 509. Sorry, here there is some mistake. It would be a total of these two divided by factor of safety. Let me check. And that will give me 224. It will be a total of 50.9 plus 509 divided by 2.5. Little mistake is here. Please note this. Now here also we will study this stratified soil, another problem. The two type of the soil is there. Previous problem, uniform soil. So this is the stratified soil. In a 12-meter length of the pile, two type of the soil, 7-meter and 5-meter. C value is 65, alpha 0.65. Here C value is 95, alpha value is 0.85. So for end bearing, we shall consider bottom cohesion. Right? So bearing capacity, cohesion is 95 kilonewton per meter square. So end bearing will be C and C into area. So 106.88 kilonewton. Frictional resistance 0.65 into 65 into 7, because it is a alpha C perimeter into depth. So perimeter will remain constant, so I have taken outside, and depth will be vary. So 0.65 into 65 into 7, below 0.85, 95 into 5, multiply by 1.20. This is the perimeter of the pipe. So the capacity is coming 87.4.38 kilonewton. So total pile capacity is 981.25 divided by factor of safety 3. So my pile load carrying capacity comes 327 kilo. Okay. Now we shall discuss a group pile, because normally pile is not provided single. Even for one column, there will be a group of 2 pile, 3 pile, 4 pile. So let's take a problem of a group pile foundation. Okay. So we take a previous problem in which we have taken a single pile. 30 centimeter dia, 9 meter is the depth. But here in a pile group, we are using 9 pile at 1.2 meter center to center. This center to center distance is 1.2 meter. I forget to write here. 1.2 meter. So individual capacity we have calculated 509 kilonewton. Here factor of safety is not given, so I have taken total capacity. So one pile take 509 kilonewton load. So 9 pile will take 4581 kilonewton. Okay. Now in a friction resistance, we shall consider the outer boundary of the pile group. Outer boundary. This will be the outer boundary. Okay. So what will be the B dimension? 2 into spacing plus dia, because there is a 3 by 3 pile. So 2 spacing 1 and 2 is there, and plus half diameter here, half diameter here. So full dia. So 2 into 1.2 plus 0.4, 2.8 meter. Here I think I have made a mistake. It would be a 0.3, not 0.4, because previous problem the diameter is 0.4. So this will reduce to 2.5. Okay. This will reduce to 2.5. Please note. Let me do make a correction here. It will become 2.5. This is also 2.5. 2.5. So this will going to be a 6.25. And when it is a 6.25, this is going to be a calculator 6.25 into 80. Sorry, 6.25 into 80, 500 kilonewton. 500 kilonewton. And 2.4 into 0.3. Wait a minute. Sorry, this is not 2.5, 2.7. Sorry, 2.7, 2.7, 2.7 into 2.7, 7.29. isn't it? Yes. 7.29. 7.29 into 80, 583.2. 583.2. This would be 2.4 plus point is this is going to 2.7. Okay, so now it would be a 4 into 2.7 into 9 into 80. So I will get 7 So 583.2. Yes, it is. Oh, sorry, 583.2, and this is going to be a 776. So total will be plus 583.2, 8359, 8359 kilometer. Sorry. Okay, and from current slide. Now I think it is okay. 1.2 meters, so 2.4, 2.7, fine. So the load carrying capacity will be minimum of these two. And in this problem, factor of safety is not given. Factor of safety is not given. So we will take actual capacity. We will take actual capacity. Okay. Now I'm stopping the sharing. And now you have any doubt? I'm making you unmute. Fanil, Divyesh and Ravi. You can take any discussion here. Divyesh,
हाँ सर
खबर पड़ी?
हाँ सर
हाँ. Fanil, તમારો વિડિયો બી ઓપન કરી શકો. આપણે 3 જ જણ છીએ હમણાં. You can open your video. Why Chetan Jariwala has left even though he is joined? Okay. અને હું રેકોર્ડિંગ બી બંધ કરી દઉં છું.